Geometry students, to the homework help video, page 498, 1 through 24. Let's go ahead and get started. Okay, numbers 1 through 10, we're going to match up the term with the proper figure down here, okay, or a line or point or a segment or whatever you want to call it. Here we go. Center of a circle, alright? Well, we have two. We have point P as the center of a circle and point Q. So let's see if any of those are listed over here. Q is right here. I don't see P anywhere. So, and actually, it has dawned on me all these answers are wide open, aren't they? Okay, guys, I'm back. We took care of that, and here we go. So, the only point I see is point Q. So, point Q would be letter A, center of a circle. Okay, letter B, interior point of circle Q. Now, here's circle Q. Interior point means that it has to be a point inside the circle, not on the circle, not outside the circle, in the circle. Well, the only interior points I see inside a circle Q would be circle Q itself, but we've already used circle. We've already used point Q right here, and then point I is also inside the circle. Okay, all these other points here lie on the circle. Okay, so point I would be inside the circle. So right here it is, point I is letter B. Alright, let's take a look at letter C, exterior point of P. And I want to be very clear about something, students. Please listen. This point here is on the circle. Got it? This point here is on the circle. Got it? This point here is inside the circle. Every other point out here is outside of circle P. So any of those points could be an exterior point of circle P. So I really don't know which one they want. Let's look at our list here and see. B or F? Well, it can't be B because B's on circle P. So it must be F. So F is letter C. Alright, letter D, chord. Well, there's a lot of chords. I mean, EF is a chord. CF is a chord. Well, there's not a lot, sorry. There's two. So we're looking for EH or CF. Well, I see both of them. So let's hold off and come back to that later and see. Let's go ahead and say that 1 or 7 could go right here. Number 1 or number 7 could go right here, okay? Alright, now let's go ahead and continue on. Let's see, letter E, okay, that takes care of the problem right there. Letter E, a diameter. Well, EH is the only diameter I see. It's the only one. So, E has to go with number 1 right here, and number 7 must be D, a chord, okay? Remember, all diameters are chords, but not all chords are diameters. Radius, well, we've got QE is a radius from here to here, and QH is a radius. I don't see any other radii at all. So QI, QE, or QH. Here it is right here, QH. That's going to be letter F. Alright, moving on to point of tangency. Now, a point of tangency is where a line is tangent to a circle. This line right here is tangent to the circle here. This line here is tangent to the circle here and here. Those are the only points of tangent. Mr. Harris, wait a second. Here's tangency right here. No, this line intersects the circle in two places. That's called a secant line. So, the only points of tangency I see are D, B, or G. And that's going to be right here, letter B. So that would be number 5, point B. Number 5 is letter G. Alright, moving on now to secant. Well, I just told you that this is a secant line right here. So line IF or IC or CF, I'm not sure what they used. It looks like it would be CF right here, I believe. Yep, CF. So line CF is a secant, so that would be letter H. Alright. Common external tangent. Now I want to be very, very slow on this. I don't want you to miss this. I'm going to draw an imaginary line from the center of one circle to the center of another circle. Got it? Now, if a line of tangency intersects that red line, like this one here does, we call that a common internal tangent, which makes sense because it's inside the two circles. It passes in between them, okay? So, this line here crosses crosses this imaginary line drawn between two centers of a circle. So this line segment here, BG, is an internal, a common internal tangent, okay? So that's going to be, let's see here, letter J for BG. Now, let me do something here real quick to get rid of a line. There we go. Now, this line of tangency right here, notice this line here is tangent to the circles, but notice it does not cross this imaginary line. It's on the external, the outside of these two circles. So we call that a common external tangent. So that's line AD. So line AD is letter I. Okay? Alright, hope this makes sense. Let's go ahead and continue on. Number 11 through 16. Okay, they tell us to find the length of these segments. Now please take some really good notes and pay attention. I'm going to take this very slowly. First of all, notice your radius is 28. Okay? So that means all of your radii would be 28. PP is a radius, so it's going to be 28. Okay? So the answer to number 11 very simply is 28. Alright? And I might change colors here to make this show up a little better. Alright, so this is 28. Now, PE. Well, guys, PE is also a radius, is it not? Sure it is. So that length is also going to be 28. So the answer to number 12 is 28. PD. Well, where's PD at? Here it is right here. Okay? Now, let's think this through for a second, okay? Let's relax and think this through. I have a right triangle right here. See it? There it is. So if I want to find this whole length right here, I've got a right triangle. So I can very easily find this entire length. I have a leg and a leg. I'm missing a hypotenuse. Do you see that okay? Leg of 28, leg of 21, missing my hypotenuse. My hypotenuse is PD. So let me get my calculator out here. I have leg squared plus leg squared equals hypotenuse, which is PD. So PD squared. Alright, let me get my calculator here. 21 squared plus 28 squared, 1,225 equals PD squared. Now take the square root of both sides, and you're going to get, well, I just messed that up. Hold on one second. You're going to get 35, okay? So 35 is the entire length of PD. So let's put that on here. 35. Alright. Now let's go ahead and take a look at number 14. 14 is BD. Now look, I don't have to do any work on BD. You don't, Mr. Earhart? No. Guys, here's where previous knowledge helps you. See this triangle right here? See that triangle right there? See this triangle right here? They're congruent triangles. Now, I'm going to show you why in a second, but if they're congruent triangles, that means this side's 28, this side's 28. They share the side here. If this side's 21, BD has to be 21, okay? Now, I'm going to show you how I knew they were congruent, and it's so simple. It is so obviously simple. Look, let me erase this 21. Now, look, I have side, angle, side, congruent to side, angle, side. Oh, I'm sorry, that's incorrect. I apologize. I mean, common sense tells you this angle here is congruent to this angle here, but you really don't know that for sure. I know what it was. You have a right triangle. There's a right angle here, and you have a right triangle. There's an angle here. So, when you have right triangles, you're allowed to use hypotenuse leg. I have a hypotenuse of this triangle congruent to the hypotenuse of the other triangle. I have a leg here congruent to a leg here. Anytime you have two right triangles and the hypotenuses, if there is such a word, are congruent and the legs are congruent, then the two triangles are similar. So there we go. If the two triangles are similar and this side is 21, this side has to be 21 also. Okay, number 15, BC. Alright, BC. Well, let's see. Here's BC right here. Now, I know the length from here to here is 28. So think about it. If I can find the entire length from here all the way to here, this little segment here, let's pretend this whole length is 50. I'm just making that up. Well, if the whole length's 50, just subtract out 28, and then you know this length right here. So my goal, students, is to find this entire length from P all the way to C. Well, look, I've got a really big right triangle right here. There it is. And I know this is a leg, 28. I know this whole leg right here is 96. 21 plus 75. So I can find the hypotenuse, hopefully pretty easily. Let's see if we can, okay? Alright, here we go. So one leg is 28 squared. Right here. The other leg is 96. So 96 squared. The hypotenuse is, let's be careful, this entire segment here is going to be simply PC. So PC squared, alright? Now, 28 squared is going to give me 784, alright? And 96 squared is going to give me 9,216. I'll put ditto marks here for PC squared. Now add these two numbers together and you're going to get exactly 10,000. So 10,000 equals PC squared. Now take the square root of both sides and you're going to get 100 because 100 times 100 is 10,000. Alright, now, so PC, the entire length from here all the way down to here is 100. So subtract out 28 and you're left with 72. So that makes sense, guys. BC is 72. 28 plus 72 does give you 100. Really not too difficult. And then PC, the length of PC, well guys, we just found that. PC is from here to here. So the length of PC would be 100, okay? 100. And there we go. And actually, if some of you did it a different way, I just saw this. If you have a right angle here, then you also have a right angle here. So you really could have found BC, number 15 right here, by using this right triangle here also. That would have worked. Look at that. Okay? You could have done that also. So either way, it's fine. Alright, moving on to number 17 through 22. Find the measure of the arc. Now you know me, I like to go through and label all the angles first. So I've got a diameter here. Okay, well, I have to work on drawing a line. You've got a diameter here. Alright? And so that's a straight line, 180 degrees. So if this is 47 degrees right here, then this next one will have to be, let's see, 133 degrees. So this angle here has to be 133 to give you 180. Now, we know when two lines intersect, their vertical angles are congruent, this angle and this angle. So if this angle is 47, then this angle over here is also 47 degrees, okay? And then if these two lines intersect, which they do, these two angles here are vertical angles, so they're congruent. So if this is 133 degrees, then this is 133 degrees. Okay, now let's go ahead and do the problems. Here we go. Arc AB. Let's find the measure of arc AB. Well, AB goes from here to here. So there's your endpoints. So where your endpoints are, draw a line down to the center, and your central angle is 47 degrees. Okay, so that if the central angle that forms arc AB is 47, then the arc itself is 47 degrees. All right, BC. Well, BC starts here and goes like this. Now, by the way, how do you know it goes that direction and not the big direction all the way around? Because they only gave you two letters, and two letters means the smaller arc less than the diameter. Okay, so BC, the endpoint of BC, the endpoints of BC are here and here. So draw this line down to the center. Draw this line down to the center. This angle forms the arc. So this arc is also 133 degrees. Alright, so BC, arc BC is 133 degrees. Number 19, A, B, D. So from A all the way to B, all the way to D. Okay, so we've got quite a few angles here, guys. It's all these angles here, 47 degrees, 133 degrees, and 47 degrees. So if you add all those angles up, 47 plus 133 plus 47, you're going to get 227 degrees. 227 degrees. students, you could add up all of these angles if you want to, but it might be faster just to take 360, which is the total distance around the circle, and then just subtract out 47 degrees. That would be fine also. So if you take 133 plus 47 plus 133, you will get 313, or if you take 360 minus 47 degrees, you will get 313 degrees. So either way, you get the correct answer. Alright, number 21, ADC, arc ADC. Let's see, A, then D, then C. Well, the endpoints are right on a diameter. And so what we have is a semicircle. See that? So anytime you have a semicircle, you know the arc is half a circle. So it's 180 degrees. Alright? 180. And then lastly, pretty easy, arc CD. Arc CD, 47 degrees. Alright? There we go. Alright, moving on to the two-word problems now. The Thomas Jefferson Memorial in Washington, D.C. is a circular building with a rectangular porch. You are standing 20 meters away, so here you are, 20 meters away from the building, and you're 49 meters away from a point of tangency. There's your point of tangency, okay? What is the radius of the circular part of the memorial? Well, we have a right triangle, do we not? Sure we do. And yes, we're missing two parts, but they're the same. The length from here to here is R, and the length from here to here is R. So we have the same unknown. So what I could do, I have a right triangle, I could use Pythagorean's theorem, okay? So I know I've got, let's see, one leg is R, so R squared. Okay? The other leg is 49, so 49 squared. Now the hypotenuse is going to be a combination of two terms, okay? From here to here is 20, and from here to here is R. So if you add those two together, you get the entire hypotenuse, okay? There we go. Now that I've showed you all that, if you need to rewind it and go back, that's fine. Feel free to do that. I'm going to move this picture out of the way so that I can get some space to work, okay? So let's move this out of the way. And here we go. Alright, let's go ahead and solve for R. Alright, first of all, on the right side, I would have R squared plus, let me grab my calculator real quick, 49 squared gives you 2,401. Now those who are a little weak in algebra, let's review this. 20 plus R squared means 20 plus R times 20 plus R, okay? And how you do that is you take the 20 and you multiply it through. So 20 times 20 is 400. 20 times, hold on 1 second, let's do something. Okay, 20 times 20 is 20 squared. 20 times R is 20R. Now take your R and multiply it through, okay? R times 20 is 20R, and then R times R is R squared, okay? And you've got two like terms you can combine. So what you end up with is 400 plus, please do not put 40R squared. It's not squared. You're just adding like terms, 40R plus R squared. Now, notice you have an R squared on both sides. They cancel out. In other words, if you bring this R squared over to the other side, it becomes negative. And they cancel out, okay? So, the R squareds are basically, well, not basically, the R squareds are gone, okay? So we can get rid of those, not have to worry about them. And now I'm simply left with a good old-fashioned linear equation, and we know how to solve these. Simplify both sides. Well, you cannot simplify this side. You cannot simplify this side. They're unlike terms. So next we get R by itself. So bring the 400 over and make it negative. And when you do that, you're left with 2,399. Is that correct? No. Oh dear. Mr. Error is pretty bad. 2001. Alright. Equals 40R. Alright. Now, divide both sides by 40. 2001 divided by 40 is going to give you 50.025. 50.025. And you can check in the back of your book. That's an odd number. You'll see that is correct. And also I can pull this down here and show you that is the correct answer. right there it is, 50.025. Okay, not too difficult. All right, number 24. They want us to make a circle graph. Okay, so we're going to have to do some percentages. Now, 300 people were asked how long they sleep. Okay, so we have 18 out of 300 sleep less than 5 hours. Okay, 48 out of 300 sleep 6 hours. 78 out of 300 sleep 7 hours. 111 out of 300 they sleep 8 hours. All right, and then 27 out of 300 sleep 9 hours. That must be really nice. And then 10 hours. Well, that'd be awesome. 18 over 300 get 10 hours of sleep. Now, understand this fraction here really doesn't equal the number 6. I'm saying that it equals 6 hours. I think you guys understand that. So I'm going to get rid of this big block here so we have room to work. We're going to construct a circle graph, list the percentage and the measure of each arc. Okay, so we're good. Here we go. Let's get to work on this. Alright, now let's start off with the 18 over 300. Grab my handy dandy calculator. 18 divided by 300, 0.06, so 6%. I'm going to change color so we can see it a little better. Okay, this one is 6%. 48 divided by 300 gives you 16%. Looks like they made these really nice whole percentages. 78 divided by 300, 0.26, which is 26%. 111 divided by 300, 0.37, which is 37%. And then 27 divided by 100, or 300, excuse me, is 0.09, so 9%. And then you can add up all of these percentages and subtract from 100, or you can take 18 divided by 300, which is what I'm doing, and you get 0.06, or 6%. By the way, I should have been paying attention. This fraction here is the same as this fraction here, so the percentages have to be the same. So you could have done it that way also. Okay, so there's my percentages. Okay, now we're going to go ahead and put these on a circle. Let's give a little bit of room here. Alright, there we go. Now, that's not what I want to do. Here we go. Alright, well, the biggest percent I see is 37%. So here's what I'm going to do, students. I'm going to draw a diameter that cuts the circle in half, okay? Looks like it's just a little low, so I'll raise just a bit. There we go. Now, I'm going to get rid of this line in a second, but if I draw a line here, that's cuts that in half. That's going to be 25% over here, or it should be anyways. So I'm going to go ahead and take this line and barely scooch it forward, just a hair. And I'm going to call that 26%. Okay? So it's good enough. You don't have to measure it exactly. So this is 26%. Okay? Now what's the arc length? Well, remember, guys, the arc length is the same as this central angle here. So if I've got 26% of a circle, just take 360 degrees times 0.26, okay? You're taking 26% of means multiply 360 degrees. So 360 times 0.26 is 93.6. So the measure of this arc is 93.6 degrees, okay? Alright, now let's cross this one off. Now we need 37%. Let's see if there's anything quick and easy I can do. If this is 26, that leaves what over here? 180 minus 26, 154. That'd be 77, 39, 18. I'm trying to cut it in half, guys. Well, if this is 26, that leaves 150. No, sorry about that. That would leave, let's see, 24%. And I'm looking for, yeah, that'll work. 24%. This is 25%. cuts that in half right here. That will be 6%. Okay, let me go over that again. This entire segment here is 26, so this has to be 24% to give you 50% of the circle. Okay, 50% of the circle, half the circle. So if this whole thing's 24, cut it in half, and that's 20. That's 12%, and then cut that in half again, and you're going to get 6%. So we'll draw this line here. Move it around if we need to a little bit. And there we go. So let's get rid of this line here. And this right here is going to be, and actually to be honest with you students, I've got to be careful here because this space right here is only going to be, what, 18%. So I think I'll move this line up here to about right there, and that'll be your 6%. Alright, so there we go. Now, if you'll take 0.06 times 360, you will get 21.6 degrees because you're taking 6% of 360 degrees. Okay, so far we got 26%, and we have 6% taken care of. Okay, now I can get rid of this line right here if I have to, but I'm kind of curious what I'm left with here. This is 18% right here. Okay, 18%. So if I can just barely, this is 26 plus 6 is 32, so this has to be 18% right here to give you a total of 50%. Okay, so this is 18. So if I can shrink that just a little, then that would give me 16%, which I need 16%. So I'm going to get out my white line, and well, first of all, I'm going to shrink it just a hair. I'm going to draw a line like this. Slide it down to here. And what I'm going to do is I'm going to take this line right here, and shrink it so it's like barely going up. There, that's probably about 2%. Now I'll get out my line, my white marker here, and I'll get rid of this line here. Okay, we don't need this line here at all. And we'll fill that in later, alright? So that line's basically gone for the most part. Alright, there we go. Alright, now this percentage here is then going to be 16%. So I'll cross this off. So I've got 16% here. And now the arc measurement, well, you're going to take 0.16 times 360. So 0.16 times 360 will give you 57.6. So the degrees here would be 57.6 degrees. Alright, so let's see what we got left here, guys. We've got 6, 9, and 37. Now, this entire area left here, I believe, is 52%. Let's see. I could be wrong. I hope I'm not. Let's see, 22, 48. Yes, this whole area is 56. So if I cut that in half, I get 26. Cut it in half again, I get 13. Cut it in half again, I get basically 6%. So that's how I'm going to try to get the 6%, guys. A lot of you might be using compasses and protractors. Totally fine, no problem with that. But I'm going to cut this in half, so it'll be a little shade that way, okay? And then I'm going to cut it in half again. So this is 26. Cut it in half again, we get 13%. And then if you cut 13% in half again, you get 6.5%, which is definitely close enough to 6% for me. So I'm going to take this and cut that in half again. And I'm going to get rid of this. Get rid of this. And there's my 6%, okay? So we'll put 6% right here. And we already know that's an arc length of 21.6 degrees. Alright, so cross that off. And now we're left with 9 and 37%. Guys, I am not a lazy teacher. You know, I believe in hard work and doing a good job with your stuff. but to be honest, if we get this close on a test or a quiz, you're doing fine. I mean, if this is 6%, you could draw a line like this, and then just make this a little bigger than 6%. That's totally acceptable with me. Be reasonable, within reason. So this looks like 6%. So we'll go out 1, 2, 3, about right there, and we'll call that 9%. Okay, that looks really pretty accurate, to be honest with you. So there's my 9%. Now, if you take 0.09 times 360 degrees, remember it's 0.09, not 0.9, you'll get 32.4 for the arc length, okay? So this leftover amount here is 37%, which would be 0.37 times 360 would give you 133.2. Now, one way to check your answer is to go through and add all 6 of these degrees, and you should get 360, okay? I'm not going to do that, but you should, okay? And you can label all this with 6 hours sleep and 7 hours, 8 hours, etc. But there's pretty much the circle graph, okay? So these degrees right here, 57.6, that's the same thing. This arc measurement right here, 57.6, is the same thing as this angle right here. You guys understand that? 57.6 degrees. Don't get percentages confused with degrees, okay? Listen to this. The percentage of this circle, the entire circle, the percentage of that entire circle is what? 100%. The degrees inside the entire circle would be what? 360 degrees. So 100% of the circle is 360 degrees. Alright? Okay. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.